Hi everyone, in this video we are going to discuss half reactions. So half reactions are basically the bookkeeping way for you to balance an overall electron transfer reaction. So just like when we looked at combustion reactions, we had to balance chemical equations, and then when we looked at nuclear power, we had to balance nuclear equations. Same thing. Now we're looking at electron transfer, and now we have to balance half reactions. So before we actually practice balancing it, let's define what a half reaction is. And one of the biggest things that I can point out to you is that a half reaction always comes in pairs. So you always have two half reactions, okay? So definition. Half reactions is a chemical equation. So it's kind of confusing because we use the word reactions, but it's technically a chemical equation that demonstrates the process of electron transfer. And even though I already said this, I'm going to write this down because I want to make sure you get this. They always come in pairs. You have to have an oxidation half reaction and you have to have a reduction half reaction. So let me show you some examples of that so that we know what it is. So let's say we have some atom, molecule, whatever it is, A, and what we're going to do is treat it with an electron and create a product B. Okay, this is what is called a reduction half reaction. And sometimes you'll see people write it like that with the fraction sign for half reaction. Both are equivalent and you're going to see both, so just get comfortable with both ways, okay? So now that's a reduction half reaction. So your electrons are on the left side. Now the opposite of this is what would be called an oxidation reaction. So an oxidation reaction could be something like B going to C plus an electron. All right, so now the easiest way to identify an oxidation half reaction is when you see that the electrons are on the product side or the right side, okay? And so the big thing that we do for this is that you always have a reduction one and you always have an oxidation half reaction, because what we do then is we bring these two reactions together to get an overall reaction. And so just like we would do in a normal math problem, when you add two things together, you cancel pieces out. So I see a B on my product side and then I see a B on my reactant side. So those two would cancel out. I also see an electron on my left side and an electron on my right side. These two are going to cancel out. So if you add these two together, your overall reaction is just A going to C. This is what's called your chemical equation. So you already know this part, right? Nothing here at the bottom has ever changed. The only thing that's changed here is now we're breaking down our full reaction into half reactions, okay? The biggest thing is that they come in pairs. You always have two half reactions, but your electrons must always cancel out, okay? So you're never going to have electrons in your chemical equation. So no electrons ever in your chemical equation. No. If you end up with A going to C plus E, you know you've made a mistake, and so you need to go back through and rebalance. All right, so now I've just said reduction, I've just said oxidation. I hope you can just kind of bear with me there while I went through that. Now let's get a real definition. Instead of electrons are on the left side. That's bad, that's amateur, okay? Now reduction is what is when a molecule or an atom, can be either, okay, gains an electron or more, okay? It can be 1, 2, 3 electrons, so it just gains an electron. And a lot of times people will write it as RED, red, okay? Now the opposite of this would be an oxidation. Let me drop that down so that my head doesn't block it. So we have oxidation is the opposite. So when a molecule, again, or an atom, it can be either, loses an electron. And a lot of times people abbreviate oxidation with just ox, okay? So now what I want to do is give you an example. And so we're going to go back to that NiCad battery. And so I'm going to give you both of the half reactions, and I want you to identify whether or not they're a reduction or an oxidation reaction. So let's start off with the cadmium aspect. We have cadmium, and it goes to cadmium 2 plus 2 electrons. And then we also have a nickel component, and so when it's balanced, when the half reaction's balanced, you have 2 nickel 3 plus 2 electrons, and that goes to create 2 nickel 2 plus, right? And that's it. Okay, so now what I want you to do is tell me, is this an oxidation or reduction reaction? Same thing, so you're going to have two questions. Go. All right, did you get an answer? Hopefully you did, but if you didn't, don't worry about it. This is something that takes a while to identify, and you have to practice as much as you possibly can until you can easily look at these and go, bam, that's reduction, or bam, that's oxidation, okay? So for me personally, I always start with my reduction reactions. I think it's the easiest one to identify, because for a reduction reaction, what you're looking for is an atom or a molecule, atom in this case, that is gaining an electron. So it has an electron on the reactant side. So this one clearly, nickel 3 plus, gains 2 electrons and becomes nickel 2 plus. So what you can see, A, is that the electrons are on the reactant side, and B, you go from a positive number to a less positive number, so 3 plus to 2 plus. So this bottom reaction is definitely a reduction half reaction. Now, hopefully, instinctively, eventually, you'll be like, okay, if this is a reduction reaction, then my other one has to be oxidation. You cannot have 2 reductions or cannot have 2 oxidations. That's never going to happen. So, but another way to identify this is you look at your reactant side and you see, okay, I have cadmium 0, and it turns into cadmium 2 plus, so it becomes more positive, which means it lost an electron, or the electrons are on the product side. So that's 2 ways to identify an oxidation reaction. So now once you have done this part, what you can do hopefully is then add together your oxidation half reaction and your reduction half reaction to get your chemical equation. So the first thing you have to do is make sure that those electrons cancel out. So I see 2 electrons on my product side, 2 electrons on my reactant side. They definitely cancel out, and now I can continue on. Now I'll check my cadmiums. I go from cadmium 0 to cadmium 2 plus. Not the same thing. I can't cancel them out. Then I look at my nickel. You go from nickel 3 plus to nickel 2 plus. Not the same thing. I can't cancel them out. So what I need to do is just bring everything down. So I see 2 nickel 3 plus cadmium 0 goes to cadmium 2 plus 2 nickel 2 plus. Okay, so this is a beautiful, beautiful, beautiful chemical equation that represents a 2 electron transfer from cadmium to nickel. And we'll get to that point. I don't expect you to be able to vocally say that yet, but we'll get there. All right, so now, how do you remember this? Are there any tricks? Yes, there's 2 very, very good tricks of how to memorize oxidation versus reduction. So let me show you my favorite, which is Leo goes Gur. All right, Leo is a lion. I grew up in Michigan, so this is the one we used. That doesn't make sense until I tell you the other one, so just hang on. So Leo is a lion. Let's draw out our lion. You start with the number 5. Then you get a nose, you get some eyes, you obviously have to add some teeth, and then a cute little body. Okay, so here's our lion, but that doesn't do anything until we find out what Leo goes Gur for. So Leo means lose an electron is oxidized. Gur, or whatever, Gur means gain an electron is reduction. This is how I learned it. This is how I know it. Personally, this is my favorite one. Now, I have learned since teaching in Texas that there's also another one, and this is called oil rig. All right, now, like I said, I did not grow up here, so I have no idea how to draw an oil rig. Oh, golly, that kind of looks like a Christmas tree or something terrible. Oh, geez, Louise. All right, just ignore that. So let's go to oil rig. Oil rig, oxidation is lost. Rig, reduction is gained. All right, so there's 2 very, very simple ways to do this, but you absolutely need to get one of them down or come up with a different one. But you need to know when you look at an equation, is that a reduction half reaction or an oxidation half reaction, okay? Practice, practice, practice. Good luck. Take care of yourself. Drink water.